Okay, so these are the questions that y'all sent me on 6.5 and 6.6 worksheets. So the first question that I got multiple times was number 13 on the 6.5. So this is this reading problem right here. The speed of sound in feet per second through air of any temperature measured in degrees Celsius is given by this formula. V, so this is the velocity, the speed of the sound, and it is in feet per second. V is equal to 1087 times the square root of t plus 273 all over 16.52, where t is the temperature. Okay, so normally it asked me for the domain and the range. So normally when I think about this domain, T being a temperature, I think that T could be anything that you wanted it to be. It could be from negative infinity to positive infinity. But this equation right here puts a restriction on that domain because you can't have a negative number underneath that radical. Okay, so remember when that's one of my restrictions for my domain, all you do is take what's under the radical and say you must be greater than or equal to 0. Okay, so I'm going to do that. So T is my domain, so it's going to be any T such that, and then we'll go over here and do some work. So T plus 273 must be greater than or equal to 0. To keep a negative from going underneath my radical, I'll subtract 273 from both sides, and T must be greater than negative 273. So that is going to be my domain. If you put it in set notation, it would look like this. Okay, if you put it in interval notation, it would look like this, negative 273, included, because it's an or equal to, all the way to positive infinity, never included. Okay, now, for the range, this is my domain. For the range, it's going to be a little bit more, I think it's more difficult, even though all you're doing is really looking at a graph. But the difficult part is trying to find that graph, okay? So I'm going to write this equation down, and then I'm going to show you. V is equal to 1087 times the square root of t plus 273 all over 16.52. Okay, so let's think about just as far as transformations. Guys, these first 3, 6, 9, 12 problems right here, all they're really asking you to do is you use your transformations. Look at this right here. This moves it left 2 and down 2. You got the square root function. He moved left 2, 1, 2, and down 2, 1, 2. He does not have any vertical stretch or vertical compression or anything like that. There is no horizontal because there's nothing in there on the X. Okay, so I can just go up 1 and over 1. There's my graph right there. Oh my word, so easy. Domain. Y'all, the domain has to do with this guy under here. He's your X. So if your X moves left, normally for the parent function, it's from 0. Look, here's your parent function. Domain, 0 to positive infinity. Range, 0 to positive infinity. Okay, look at this guy. What happened to him? He moved left 2. So my domain, instead of being from 0 to positive infinity, now becomes negative 2 to positive infinity. My range, this guy has to deal with the range. He's a Y. So he went down 2. So now, and if you wanted to, you could use your finger and read your range. You could start at the bottom because we're doing interval notation. Keep having to look up here and see if you can see it. And then just go up until you hit your graph. I hit my graph right here. That's at negative 2. So your range would be from negative 2 inclusive all the way to positive infinity. Okay, well, look at this one. Let's look at this one. Let's talk about it. Okay, so first of all, this guy out here is 1087 divided by 16.52. I don't know what that is. I don't know. I don't know what it is. I could do it in my calculator real quick, but it's a positive number and it's bigger than 1. So it is going to be a vertical stretch. So while I know my graph is looking like this parent function, he has a vertical stretch. So I know he's going to go up a lot faster, okay? What does that positive 273 do to him? He moves him to to the, to the left all the way, I got a Critty pen, to negative 273. So now he's here, and then he just has a big vertical stretch on him. That's all it is. That's it. It's a square root function. Okay, no big deal. So what I'm going to do is I'm going to put this in my calculator, and I'm going to try to find my graph, because I taught y'all to do the range just by looking at your graph. Okay, so I'm going to turn it in. There's my equation. I've already put it in for you. Okay, I'm going to do just what y'all would do, which is normally everybody just slaps it in, and then they go graph, and they don't check anything. So I'm going to go zoom 6, because normally that's what your graph is stuck on. And then that's when everybody brings their calculator and says, Miss Davis, my calculator's broken, it won't work. But that's not the problem. The problem is you're not looking at the right, y'all, this went left, negative 273. This is negative 10. I'm not even looking in the right window, okay? So I'm gonna put it in a little bit of perspective. So I'm gonna go to my windows. Let's just go from negative 280 to positive 280 on the x's. Okay, I don't really care about your scale, but if you don't like that big fat line, like when you go by ones, you could go by like 25s or something like that, okay? Now, let's talk about the y's. Now, obviously, I'm not gonna, look, I'm not gonna have any negatives down here, okay? So I'm only having positives. I know it's gonna go up pretty fast. I mean, you know, if you needed to, if you needed to, you could do your 1087 divided by 16.52. And you could see that that's a vertical stretch of 60, almost 66. Okay, so that means he's going up 66 and over 1, but you can only do that one time. Remember, it's not a slope because your line's not straight. So you can only go horizontally 1 unit. So if this had been a 1/2, I could go up a half and over 1. You cannot go up 1 and over 2. You can only move horizontally 1 unit to use that kind of like a slope on your curves and stuff. Okay, so I'm going back to my windows. I'm trying to choose some windows for my y's. I'm thinking they're going to be really big. They don't go below 0, so I'm just going to go to 1,000. I don't really know, okay? I don't really know, but I'm just going to go to 1,000 and see what happens. Okay, so now when I graph it, I can see what it's done. You can't see that just because, I mean, it goes all the way back down there. But I may have cut it a little bit close there when I did the negative 280. Is that what I did? Yeah, negative 280. All right, so there's my graph. So what is my range? Well, I mean, here it is, people. There's your range. There's your picture. Your range goes from 0 to positive infinity. Okay, so my range. Set notation looks like any v such that v is greater than or equal to 0. Interval notation looks like 0 to positive infinity. Okay? Now, number 14 asks, what is the temperature of the air if the speed of sound is 1250? This is what it looks like. It's this problem right here. What is the temperature of the air? So you're looking for this T when my velocity, that's this V, is 1250. People, I mean, look, are they leading you into problems like these right here? Yeah, they are. That's like a teaser. Could I use my calculator to do it? Yes, it's a real life problem. I always tell you to use your calculator, okay? So I'm going to use my calculator, and then I'm going to go and show you how to do it algebraically. Okay, so the problem with this is that actually what I'm trying to find, when V is 1250, what is T? Okay, so look, this is my Y's. These are my Y's. Look at my window. It only goes up to 1,000. Okay, so I'm going to need to change that, because really what I'm going to do is I'm going to go to y equals. I'm going to go down here and I'm going to put that 1250 in y equals. It's going to make me a horizontal line, and I'm going to want to know, where does that horizontal line intercept this curve? And that x value, that's going to be my temperature. Okay, but I do have to go back and change this window. So it has to be at least 1250, so I'm going to go 1300. I'm going to graph it. There's my curve. And there's my little line I'm looking for. There's my intersection. So I'm going to go, second and calculate. Number 5 is an intersection. I've been working in the garden. My fingernails are nasty, sorry. First curve, yes. Second curve, yes. Don't want to guess. So this is the number that we're looking for. 80, I can't see it. 87.895. So 87.90. Okay? Now, if you wanted to do it algebraically, that's what you learned in 6.6. So what you would do is you would take this equation and set it equal to the 1250. Okay, let me make sure y'all can see all that. Yep. All right, so here's the deal. This was the object of that game, right? Was to get this radical all by itself. So anything that's outside the radical, you have to get rid of. So what I'm going to do is I'm going to multiply by the 16.52. That's going to get rid of this. And then I'm going to divide by this guy right here, 1087. And what you do to one side, you always have to do to the other side. So the other side, I'm multiplying by 16.52 over 1087. Okay? Over here, these two canceled out, and these two canceled out, and that isolated my radical. Okay? Over here, I didn't do it in my calculator. So, well, maybe if I don't break it. So I'm going to go 1250. Times. I could use a fraction if you wanted to, but you don't have to. I'm not going to. I'm just going to go 16.52 divided by 1087. And there's my 18.997. All right. Now, once you've gotten your radical isolated, you've got to get rid of it. This is a square root function, so we're going to raise it to the second power. Y'all, if it were a cube root, you'd raise it to the third power. If it were a fifth root, you'd raise it to the fifth power. Whatever power you need to get rid of that radical, okay? And that's going to be that index number. So this is squared. What you do to one side, you do to the other. This squared takes care of that square root. It removes it. They're opposites of each other, just like adding and subtracting, multiplying and dividing. Over here, I'm going to take this number, and I'm just going to square it. He's going to tell me it's 360.895. I'm going to solve for t, so I'm going to subtract 273. So I'll say minus 273. And I will get 87.895, which is 90, and that is the same answer that we got on our graph. Okay? All right. Remember that anytime it's a word problem, a real life problem, an application problem, that you can always use your calculator. I don't have to see this. I'm okay with this. You used your calculator, I assume, and got your answer. Okay? All right. So the next problem, let me see, 13, 14, 14. Okay, I think someone asked about this question. They said 14 on 6.6, so I'm assuming it's this problem right here. Now, I'm going to warn you right now that I may not work all the way through these problems, but I think I'll get you far enough to address the problems that you had, okay? Remember that in the directions it says solve the equation and check for extraneous solutions. Whenever you're raising something to a power to get rid of a power or a radical, that could create extraneous solutions. So you always want to check your answer, okay? If it's the correct solution and it does not check, that's an extraneous solution. Do not put it in your your solution set. Okay, remember we just put an X over it so that people can see that we found it, okay, but that it didn't check, all right? And then your solution set would contain the correct solutions that checked. So here's number 14. 3x plus 21 raised to the 4/3 plus 9 equals 90. Okay? So the first thing you want to do, y'all, it's just the same as a radical. This is the third root, the cube root of 3x plus 21, all raised to the 4th power. Okay? But we don't want to write it that way, okay? I have a little help back there. All right, so the first thing I'm going to do is I want to get whatever is raised to this power all by itself, okay? So I need to get rid of this plus 9, so I'll minus 9 from both sides. So that will leave me with 3x plus 21 raised to the 4/3 power is equal to 90 minus 9 is 81. This is when I miss y'all. I wish y'all were here to tell me what that it was. All right, so now what you want to do is I want to raise it to a power to make this power go away. Well, powers to powers, you multiply your exponents. So really what I want to do is I want to multiply this by his reciprocal. All right, so I'm going to raise this to the 3/4 power. Now, see when I multiply any number times its reciprocal, these 3's cancel out, the 4's is 1. So I'm just left with 3x plus 21. But what you do to one side, you have to do to the other side. So this is also to the 3/4 power. Okay, so if you remember about rational exponents, those are fractional exponents. Roots grow on the bottom, powerful things are on top. Okay, so this is my root and this is my power. Always try to take your root first. So we're going to take the 4th root of 81. Remember, a 4th root is this, it's like backwards from a 4th power. Remember how I said you don't have to memorize 4th powers because all you do is square them and square them again? Okay, well, roots are just the same. The 4th root, we're going to take the square root and then take the square root again. So the square root of 81 is 9, and then the square root of 9 is 3. So the 4th root of 81 is 3, and then I have to raise it to the 3rd power. Okay? Follow your PEMDAS. You have to raise to the powers first. So 3x plus 21 equals 3 to the 3rd power is 27. Simple algebra 1 problem. I'm subtracting 21 from both sides. 3x is equal to 27 minus 21 is 6, and I'll let you go on and finish it. Remember, when you check it, you always check it back in here. If it makes a true statement, then it is an answer. On this one, you would do it all in here first and then take the cube root. Y'all, I'd slap that in my calculator and check it. But if you wanted to check it by hand, you would multiply 3 times 2. Plus 21, that's 27. The cube root of 27 is 3. 3 to the 4th is 3 squared is 9. 9 squared is 81. 81 plus 9 is 90. Okay? Now, the last one is 17. And 17 looks like this. The square root of 2x plus 3 is equal to 1 plus the square root of x plus 1. Okay, hang on for a second. I'm going to get me another colored pen. Okay, so this one has 2 radicals, all right? So really, you just have to isolate one radical. It doesn't matter which one you do. This one's already done, so, you know, I'm going to leave it that way. Okay, so I'm going to square both sides. Now, this is where I think the mistake is happening, all right? When I square this radical, it makes it go away, and you're left with 2x plus 3 is equal to. Guys, You're squaring a binomial. Like it's been since November, October, November. All right, this is chapter 4 when we learned how to square a binomial. You square the first, keep the sign, twice their product, plus square the last. And some of y'all forget that middle part and you just like square the first, square the last, and then you try to go on and it won't work. Okay, so square the first. 1 squared is 1. Keep the sign, plus. Twice their product. Y'all, their product is 1 times this radical. So their product is 1 times the square root of x plus 1. What's twice that? 2 times the square root of x plus 1. Plus, square the last. When you square this last, it just removes the radical. So you got x plus 1. Okay? I always suggest that you collect your like terms on both sides before you start moving stuff around and everything. These are my only like terms right here that I can collect. So over here, it stays the same. 2x plus 3 is equal to, I'm going to put this guy first. 2 times the square root of x plus 1 plus my x. And then 1 and 1 make 2. Okay, so now you have to do it again, okay? I have to isolate this radical right here. So the first thing I'm going to do is get rid of these guys right here. The last thing I'll do is get rid of the 2, okay? So I'm going to subtract x from both sides, and I'm going to subtract 2 from both sides. These cancel. 2x minus x is x. And 3 minus 2 is 1. So now he looks like this. Can I square it right now? No, you can't because the radical's not by itself. I need to get rid of this 2. So we'll just divide both sides by 2. This 2 goes away and you're left with x plus 1. Over here, you have x plus 1 over 2. Now you're going to square both sides, okay? This is as far as I'm going to go, okay? So I know that when I square this side, it will get rid of the radical. I will have no more radicals, okay? I know when I square this side right here, I will not get x squared plus 1. You have to follow the same rules we talked about right here. Square the first, keep the sign, twice their product, plus square the last. And then 2 squared is just 4. After that, you're going to have something on the top and then a 4 on the bottom. Over here, you'll have an x plus 1. I would get rid of this. I would just multiply both sides by 4. This 4 will disappear. Now look, you got the stuff there. I'm not telling you what it is. And over here, you'll distribute. You'll need to set that equal to 0. It'll be a quadratic. So you'll have to factor and solve. If it won't factor, you'll need to use the quadratic formula. Okay? So this is the way we're going to do it. Those were the only ones that anybody wanted worked. Okay? So on your next worksheet, you'll have a little more time because I'll give it to you before like Tuesday or something. And I'm going to put them all in there. Today's Friday. So I'll put them all in there either this evening or tomorrow. I'll put all the rest of your worksheets. And then like a day or so before they're due, like let's do Thursday. The next one's going to be due on Friday, and then the next one I think is due on, no, y'all's are all due on Friday. So maybe on Thursday, maybe I'll give you Wednesday till Thursday at 10. I'll say, send me any ones you want to see worked. So I'm trying to help you not procrastinate. Don't procrastinate. And then I will work them and shoot them out to you after I get them all worked and videoed. Okay? All right. Text me through Remind or the chat thing if you have any more questions. All right. Bye, guys.